Okay, so this is the overall process for translation in prokaryotes. So we're going to start off with initiation. In initiation, a Shine-Dalgarno sequence, shown right here, is needed for the ribosome to be able to find the start codon, which is the AUG, and to stabilize the small subunit onto that area. IF3 attaches to the small subunit to prohibit a larger subunit from coming in and attaching on top right there, on top of the mRNA to form a full 70S ribosome. So we begin with a charged tRNA with FMET, which is the corresponding amino acid with the AUG. It's right there. By adding the charged tRNA, IF2, which is initiation factor 2, initiation factor 1, and GTP. The charged tRNA attaches to the start codon right there, and IF2 and GTP form a complex onto the charged tRNA, and this is on the A site of the ribosome. IF1 just attaches to the small subunit of the ribosome. So from there, the GTP is hydrolyzed into GDP and 1-phosphate shown there. And when GTP is hydrolyzed, everything leaves, all the initiation factor leaves. And a large subunit is now allowed to come in and bind right there on top of the mRNA, forming a full 70S ribosome. So from there, we're moving on to elongation. In elongation, you start off with this complex and you add a new charged tRNA and elongation factor TU in a GTP complex. The new charged tRNA is now on the A site, it binds to the A site right there, and the TU GTP forms a complex onto the new charged tRNA. So from there, GTP is hydrolyzed, allowing the elongation factor to leave, and GTP to be transferred into GDP and just a phosphate. Elongation factor TS rehydrolyzes that GDP and phosphate into a new GTP that is used again in a later process, in the same process but later on. So next, peptidyl transferase comes in and forms a peptide bond between these two, right there, those two amino acids in the P site and in the A site. And then the amino acid in the P site is kind of released from that and just starts forming this chain-like bond with the new amino acids. And then next, the ribosome right here is being translocated. So that basically means that it's being moved down the mRNA. And when this happens, it requires elongation G and a GTP to allow this process to occur. And the tRNA from the A site is moved down to the P site, and the one that was already in the P site is moved down to E, which then is released into the cytoplasm over here. So next is going to be termination of translation. This is our last step. And in termination, a stop codon, shown right there, the UAG, is present in the A site, which means that no tRNA is able to come in and bind and keep on elongating the chain. So this signals that release factors need to come in, and release factor 1 comes in and binds to that A site, and release factor 3 forms a complex with GTP and binds to the ribosome, causing the polypeptide chain right here to be released from this charged tRNA in the P site. With this, the GDP is hydrolyzed, and everything is allowed to be released. That includes the large subunit, the small subunit, the charged tRNA, the RF1, and a GDP and phosphate. And that is the complete cycle of translation. One thing I want to go over real fast is that in initiation, the initiation factors are used from IF3 to IF2 to IF1. In elongation, the elongation factors are used from EF to U, and then EFTS to EFG. So from there to there to there. And then in termination, RF1 and RF3 come at the same time, and RF1 binds to the A site, and RF3 and a GTP bind to the ATP. I mean, that's so wrong. Bind to the ribosome. Okay.